Hello everyone. In the next class, we are going to see the topic of critical path method. Okay. So critical path method is a method to find what are the different ways that we can finish the work. Mostly this critical path method and PERT method is used under the construction programs. Construction of dam, construction of a building, the construction of a house. So how many different activities are there? How many different ways we can finish the work and how much time will it take to say construct a dam? So when we know that what is the time that is needed, it is easier to calculate the cost also. Okay, so in this question, we have given different activities and we have given the durations for each activity. So there are two questions asked, that is, we have to draw the network diagram and then we have to draw the critical path, calculate the critical path and the duration of finishing the project. Okay, so here the basic thing that we have to understand is the arrow. Okay, the arrow, the first front part of the arrow is known as uh, the starting activity. The end of the arrow is known as the finishing activity. Okay, the activity that one and that circle behind is called as nodal. Okay, so the first drawing the network diagram is easy one. We just have to follow the activity sequence that is given in the question. Okay, so here it is given 1 to 2. So we'll draw the activity 1. Then we'll draw an arrow that the activity is starting from 1 and it is ending to 2. So 1 to 2. Then the second one is 1 to 6. So we draw a line from activity 1 and it will end to activity 6. The next activity is 2 to 3. So activity 2 is the start and ending is at activity 3. Then 2 to 4. Then we have the activity starting at 2 and then it is ending at the 4. Then if you see that activity 3 to 5 and 4 to 5, that means both the activity starting point are different, but it is ending at the same activity. That is 3 to 5 and then 4 to 5. Then we have the activity of 6 to 7. So activity starting at 6, it is ending at the 7. Then we have the activity 5 to 8. So activity starting at 5, ending at 8. Similarly, 7 to 8, activity starting at 7 and ending at the 8 activity. So we have this network diagram where the activity of the production of any project has started from activity 1 and it has ended with activity 8. Now, if you see that there are different paths to reach from activity 1 to activity 8. We can reach from 1 to 2, 2 to 3, 3 to 5, and 5 to 8. Or we can go from 1 to 2, 2 to 4 to 5, and 5 to 8. Or 1 to 6, 6 to 7, and 7 to 8. So this way we will easier to understand that how many different ways are there to complete the project from starting the activity 1 to ending the activity at the last activity 8. Okay, so this is your network diagram. Here, the time is given, the month, duration is given for each activity. You will mention this activity on the arrow. Above the arrow, you will mention these activities. So this is your first question, that draw the network diagram. In network diagram, it is easy. You just have to follow the sequence that is given in the question. Okay, so now next. Next, this is what I saw that told you that there are different paths to finish from activity 1 to activity 8. So 1 to 2, 2 to 3, 3 to 5, 5 to 8. Path 2 will be 1 to 2, 2 to 4, 4 to 5, 5 to 8. Path 3 will be 1 to 6, 6 to 7 and 7 to 8. If you calculate the durations of different paths, the duration is given in the question. The 1 to 2, 2 to 3, 3 to 5, 5 to 8. The durations will be 7 plus 14 plus 11 plus 4. That is 36 months it will take to finish the construction. If we take the duration of path 2, 1 to 2, 2 to 4, 4 to 5 and 5 to 8, the durations will be 7 plus 5 plus 7 plus 4. 23 months it will take to finish the construction. In part 3, the duration of part 3 will be 1 to 6, 6 to 7, and 7 to 8. 6 plus 11 plus 18, 35 months it will take to finish the construction. Now let's see how to calculate the critical path in the CPM. Okay. Now you see we have to draw a rectangle with two cells in this above each activity. Above each activity, above activity 1, activity 2, activity 3, 4, 5, 6, 7 and 8. Above each activity there will be a rectangle with two cells. The cells that is below, that is down, it is known as EST. It is called early start point time. Okay, EST, early start time. The cell that is above, the above one, is known as LFT, latest finishing time. So, a rectangle with only two cells. The down cell is known as EST, early start time. The above cell is LFT, that is latest finishing time. Okay, now how to calculate the EST and LFT? Now, first, let's see the EST. Early start time is that we will move forward. Okay. So, the first activity, when we are going to start the construction, the number of weeks or the days, the duration has passed is 0. There is no work done in the construction. So, it will be taken as 0. Okay. Then it is simple that whenever we are going forward, we just have to add the duration with the EST. Okay, so in the first activity, the EST is 0 and the duration between 1 to 2 is 7. So I'll just add 0 plus 7, I'll get 7. So the EST for activity 2 will become 7. Okay, you understand? The EST of the first activity, the previous activity, plus duration will become the EST of the next activity. Okay. So if we see 1 to 6, the EST of activity 1 is 0. Duration of the activity 1 to 6 is 6. So 0 plus 6 is 6. Okay. So now go to 2 to 3. The activity 2 to 3, the EST of activity 2 is 7. And the duration of activity 2 to 3 is 14. So 7 plus 14 is 21. Likewise 2 to 4. The EST of activity 2 is 7 and the duration of activity 2 to 4 is 5. So 7 plus 5 is 12. Now, if you see that 3 to 5 and 4 to 5. Now both the activities are ending on the same activity. Right. So we will have 21 plus 11, that is your 32. We will have 12 plus 7, that is 19. Now what we have to consider for the EST as activity 5 is the maximum value that is coming. Okay. So the rule is whenever we are having a tie on any activity. Okay. So in the time of EST, you have to take the maximum value. Okay, so the EST of 3 is 21. The duration of 3 from activity 3 to 5 is 11. So it is 32. EST of activity 4 is 12. The duration between of 4 to 5 is 7. So it is 19. So if we compare 32 and 19, which is the greater one? 32. So we will take 32 as the EST for activity 5. Okay. Now, here again there is a tie. We have to go for 5 to 8 and 7 to 8. Let's first get the EST for activity 7. So, EST for activity 6 is 6. The duration of activity 6 to 7 is 11. So, the EST for activity 7 is 6 plus 11 is equals to 17. Okay. So, now as I told earlier, whenever there is a tie, you have to take the maximum value. So 32 plus 4 is your 36. 17 plus 13 is your 35. So 36 and 35, which is maximum one? 36. So the EST of activity 8 will be 36. So this is how we calculate EST. Okay, EST is moving forward. Okay, and we will add the duration with the previous activity EST to get the EST of the next activity. Right? So now we have reached to the last activity and we have calculated the EST of last activity as 36. So we'll give the same 36 as the LFT. Okay, now when we go for LFT, that is latest finishing time, we have to move backward. EST is moving forward, LFT is moving backward. We have to go from activity 8 to activity 1. Okay, so it is an opposite of EST. EST goes from activity 1 to activity 8 and it will add all the durations. Whereas LFT will move backward and it subtract all the durations. Okay, so here we have to go from activity 8 to 5. The LFT is 36. So 36 minus 4 is your LFT of activity 5 is 32. Whereas LFT of activity 8 to 7, so LFT of activity 8 is 36. The duration is 18. So we'll subtract 36 minus 18 is your 18. So LFT of activity 7 is 18. So we have to subtract the LFT of the previous activity minus the duration. We will get the activity of the LFT of the next activity. Okay. So we'll go from activity 5 to 3. The LFT of activity 5 is 32. The duration of activity 3 to 5 is 11. So we subtract 32 minus 11 is 21. Whereas the activity 4 to 5 duration is 7. So LFT of activity 5 is 32. So 32 minus 7 is 25. Okay. Now activity 6 to 7. The LFT of activity 7 is 18. Duration of activity 6 to 7 is 11. So 18 minus 11 is 7. So LFT of activity 6 is 7. Now if you see the activity 2. Okay. Now it is there is a two activities that is coming to activity 2 is activity 2 to 3 and 3 to 4. So whenever there is a tie in LFT, that is latest finishing time, we have to take as a minimum value. So the LFT of activity 3 is 21. Duration of activity 2 to 3 is 14. So 21 minus 14, okay, we get 7. The LFT of activity 4 is 25. The duration of activity 2 to 4 is 5. So 25 minus 5 is 20. So we'll get the value of 7 from activity 2 to 3 and the value of 20 from activity 2 to 4, which is minimum 7. So we'll take 7 as the LFT value for activity 2. Again, we will get a tie from activity 1 to 2 and 1 to 6. Okay, so if I subtract that, the LFT of activity 2 is 7 minus the duration of activity 1 to 2 is 7. So 7 minus 7 is 0. The LFT of activity 6 is 7. The duration of activity 1 to 6 is 6. So 7 minus 6 is 1. When we compare 0 and 1, the minimum value is 0. So we will consider the LFT of activity 1 as 0. Understood? So there are 2 points. One is EST and one is LFT. We'll draw a rectangle on each activity with 2 cells. The down cell is called EST, the above cell is called LFT. EST is moving forward. So we will add the previous value of EST, previous activity value of EST plus the duration of the activity to get the EST value of next activity. Whenever there is a tie, whichever having the maximum value will go for the next activity EST. Whereas LFT is opposite of EST, we have to move backward. We have to subtract the activity LFT activity minus the duration to get the LFT of the previous next activity. Okay. Whenever there is a tie, we have to get the minimum value. Okay. So like this, if you do, you will get the EST and LST value for all the activities. Once you find the EST and LFT value for all the activities, you have to consider the activities where EST is equals to LFT. Okay, EST is equals to LFT. So what are those activities? Activity 1, 0 and 0. Activity 2, 7 and 7. Activity 3, 21, 21. Activity 5, 32, 32. Activity 8, 36, 36. So you will mark these activities. So 1 to 2, 2 to 3, 3 to 5, 5 to 8. So these activities are your critical path. So wherever the EST is equals to LFT, those that path is considered as the critical path. So 1 to 2, 2 to 3, 3 to 5, 5 to 8 is considered as the critical path. Now we have to add the duration of this critical path to get the duration of the project. So 7 plus 14 plus 11 plus 4 is equals to 36, and it is your duration of the project. 36 months is the duration of your project. Okay, so I'll just have a repetition of the whole sum. The activity will be given, the duration will be given. So there are two questions. One is draw the network diagram. Second part is calculate the critical path and the duration. So first, for network diagram, you just have to follow the activity that is given in the question. 1 to 2, 1 to 6, then 2 to 3, 2 to 4, 3 to 5, 4 to 5, 6 to 7, 5 to 8 and 7 to 8. You have to draw the arrows between the activities. Okay. And then you have to mention the duration that is given in the question. This will be the first part as draw the network diagram. Second part, to calculate the critical path or duration, you have to calculate the EST and LFT. EST is moving forward and LFT is moving backward. EST, you have to add the previous activity EST with the duration of the activity to calculate the EST of the next activity. And when there is a tie, you have to get the maximum value. Okay, then when we are going for LFT, we have to subtract the LFT value of the activity with the duration to get the LFT of the next activity. And whenever there is a tie, we have to get the minimum value. So this is your critical path. So wherever the EST is equals to LFT, that path is considered as the critical path. And when you add the duration of that critical path will become the duration of the project. Is it clear? I think it will be clear for all the students. Thank you.